Hi everyone, and welcome back. I think I'm going to bring in some pencil today, but I have my trusty calligraphy pen, so we're going to start with this, but answer a question. And this is probably the most important question really in all of chemistry, because with chemistry we're talking about atoms, and so it makes sense to start with this question of what is an atom? I would say that this is an important question to ask, whether or not you don't know any chemistry, or you know a little bit of chemistry, or even if you know chemistry really well. It is important to reflect on what is an atom, and then how do atoms come together to make everything around us, everything in our universe. So we're going to be talking about all the parts of an atom. That's really the basics of chemistry. So one of the first things I wanted to start out talking about is that there are particles. So a particle, here we go with the pencil, check it out. Okay. Particles, they can be neutral, which means that they don't attract or repel anything that is charged. So a charged particle can be either positive, so as a charge is positive, kind of like when you look at a battery and it's got a positive end and it's got negative. Like if you look at a 9-volt battery, one of those electrodes at the top would be labeled positive, the other one negative, or like a AA battery, one end is positive, the other end is negative. So a particle will be either neutral or charged. And if you have two particles, and I'm gonna put circles around them. Two particles that are positive, they will repel. Okay. So there are physical forces between them where they actually will be more stable if they move away from each other. And you can see this sometimes with a magnet. If you have two magnets where you have the two positive ends close to each other, they'll push away from each other. So those are magnetic forces. We're talking about electronic forces, but it's a similar kind of idea. Okay, but if you put two particles next to each other that have opposing charges, positive and negative, and they attract. So these two ideas I wanted to introduce before we start talking about the details of what is an atom, because this will help us understand a little bit better about what is the structure of an atom and how do atoms come together to form everything around us. Alright, so an atom, the structure of the atom. I think I want to move this up. Okay. So our structure. So what we have are protons, protons are particles that are positively charged. We also have neutrons. These are neutral, so I'm going to put like a 0 in there. So they are not attracting anything or repelling anything to any significant degree. Okay. Then we also have electrons. These are negatively charged. Okay. Now, you may have heard of something called a quark. Those are subatomic particles, meaning that if you break apart a proton, it's made of quarks, and we're not going to talk about that. Okay, so that is getting into a whole nother realm called particle physics, and it's really cool and really interesting, but in terms of chemistry, it's not really relevant, okay? Because in chemistry, we are just talking about atoms and how they come together and all the aspects of the atom as a whole. Okay, so the other thing I want to mention is that these two are very similar in size. And they are about 2,000 times more massive than the electron. Okay, so these are quite large, and comparatively speaking, electrons are tiny. So these are the three components of an atom. Okay, so now the question is, where are they? And how is it relevant that we have this positive and negative charged particles? Okay. So the structure looks like this. We have something called the nucleus that's in the center. And the nucleus has all of the protons that are in an atom are in the nucleus. Now, you might be wondering, hey, wait a minute. She just said that the same charge repels each other. Okay? Now, that is true. There are repulsive forces between them, but there's also a really amazing, strong force that does keep them together in a nucleus. So the nucleus of atoms is a very special place. And we also have neutrons that can be there as well. Okay, so I'm going to put some neutrons. Now this is just an example of one of many possible nuclei. The nucleus. This is one particular element. So I just want to use this as an example. Okay. So this nucleus that I'm showing here has 3 protons and 2 neutrons. Okay. Now, an atom by itself, it is overall neutral. So that means we need electrons to counteract or balance out the positive charge that's in the nucleus. So this atom here, that means we have electrons. Okay. So you might imagine that we could just put electrons in here too, and they would all attract each other, and that would be the atom. But that is not the case. In fact, in the 1800s, there was a scientist who thought that, yeah, maybe they're all just kind of mushed together in a pudding. He called it the plum pudding model of the atom. So, turns out that is not the structure of the atom. Instead, the atom, this is one of the most amazing things about the atom, is it is a lot of empty space. The electrons, they spend their time in this outer periphery. Okay, so we've got electrons that are way out here. Remember, they're a lot smaller, less massive. Okay, and they're just, I'm going to scatter them around. Okay, so they are out here. Now, they are, like I said, balancing out the positive charge. And because in this atom here, we've got 3 positive charges, protons, that are in the nucleus, then that means we needed these 3 electrons to make this neutral atom. Now it just so happens that this example I'm showing happens to be the element lithium. Okay, lithium, that's the symbol Li, but I'll write out the word here. Lithium. Okay, has 3 protons. You can actually change the number of electrons in any element, and it will just change the overall charge of it. But you can't change the number of protons. Once you change the number of protons, it's actually a different element. For example, helium, just as a contrast, has 2 protons. Okay. Now I wanted to say something else about the relative distance and size of our nucleus and of where these electrons are. Okay. And I'm going is, maybe I'll move over the paper a little bit. And that is, I'm going to draw the nucleus a lot smaller. Let's see if I can do this. Here's our 3 protons. Okay, so that makes this lithium, since there's 3. Now, it just so happens that this particular lithium atom I'm drawing also has some neutrons in them. The neutrons, they're just adding extra mass, and they help with the stability of the nucleus. Okay, so you don't need to worry too much about them, or worry about, oh, how can I figure out how many neutrons there are, until you get deeper into chemistry. So, just for understanding what an atom is, just knowing that there are neutrons is really all you need to know right now. Okay, but you do have this tiny nucleus where these are clustered together. And relatively speaking, you have the electrons that can be way, way out. Anywhere. Well, not exactly anywhere, but generally speaking, they're way, way far away. So what I want you to imagine is that if we were able to expand the diameter from one end to the other, to the size of a soccer. Okay. And in the United States, we call it soccer, some places football or football. Okay. But regardless, a playing field. Okay, so we're going to imagine an atom that is as big as a playing field. Okay, so that means that the electrons can be buzzing around in this area here, and you can think of them almost like a swarm of bees. Okay, so they can be here, like there could be an electron here, and then another instant it's here, another instant it's here. Okay, so ultimately, as they're jumping around, they are taking up this whole space that is roughly a sphere. Okay, it's round, generally speaking. It's taking up this space. So it's a swarm of bees, right? Okay. Now, so we have taken this area in which these electrons can exist, but we expanded it to the diameter to be close to something like a soccer field. And relative to that, the size of the nucleus, where these protons and neutrons are clustered together, is the size of a pea. Okay, nucleus takes up the size of a pea. Very, very tiny. The size of a pea compared to a soccer or football field. Okay, so those electrons have lots of space that they roam. Okay, but they are, because they're negatively charged, they're they're attracted to the positive charge of those protons, and they're relatively stable. Okay. And then what they can do is there's different possibilities of how atoms can come together to form molecules, or to form something like paper, okay, or the graphite on our pencil. There are many different ways that the atoms can come together to form all these different kinds of compounds and things. But the basic, fundamental structure of everything comes down to this one beautiful little entity that is an atom, where we've got our protons, usually some neutrons, in this tiny area in the center, and then these electrons are moving around here. Okay, and in chemistry, I'm going to move this over here. Chemistry. When we consider what's happening in chemistry, we are looking at atoms. Atoms and molecules. And you might ask, well, what's a molecule? So let me just sort of define that. That are attached together. Okay, so each different molecule is a different combination of atoms that are attached together a specific way. Okay, so chemistry, we're looking at atoms and molecules. And essentially, the behavior of the electrons are either shared between atoms, or maybe they're transferred between atoms. Okay, so we can form our molecules by having them shared. We can also make other kinds of compounds that are a little bit different than molecules, where the electrons have been transferred from one atom to another, and they give you an atom that overall is charged. And so the two charged, we call them ions now. Okay, so I'll put this. So we have atoms and molecules, and we also have ions. Okay. So we also have ions that exist. So if you add an electron or remove an electron from an atom, then there will be this imbalance between protons and electrons no longer are they equal if you've removed an electron. Like I said here, transferred between atoms. If you have an electron go from one to another, then one of the atoms will end up being positively charged. The other one will be negatively charged. Now we call them ions because they're charged, and those can attract each other. So let's look at some examples. I'll show you 3 examples of an atom that we see in everyday life, and one would be helium. So helium has the chemical symbol He. Helium has 2 protons, 2 neutrons. It's very common for helium. So a neutral helium atom, you would expect, has how many electrons then? There's 2 positive charges. To balance out the 2 positive charges, we would expect out here in the periphery there will be 2 electrons. Helium exists as just one atom by itself. So when you get a helium balloon, it's got just a whole bunch of them, but single helium atoms that are floating around inside of that balloon. And because helium is quite small compared to nitrogen and oxygen that makes up our regular air, then that's what causes the helium balloons to float up, since they're so much lighter. There's an example of an atom that's in everyday life. A molecule let's look at oxygen, since I just gave that example. So this is where 2 oxygen atoms are together. So like with oxygen gas that we have in our air, it exists as O2 because there are 2 oxygen atoms that are bonded together. And so we've got with oxygen has 8. So this is going to take a little bit, but we've got 8 of these protons. 6, 7. I'll just put this one over here. Okay. So we've got these 8 protons, and what it does is that there's actually also neutrons, but I'm going to ignore those for now. And then we have another oxygen atom over here. 3, 4, 6, 7, 8. Okay. This oxygen over here has its 8 protons in the nucleus. And then what they do is so I'm going to draw, they share electrons to make each atom more stable. So each one of these atoms atoms, it still has each of those 8 electrons that are around the outside. Okay. But many of them are shared by both of the atoms. But overall, we end up having a total of 16. Now, I have no idea how many electrons I've drawn at this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. Oh, did I make too many? Maybe I made too many. Okay. So, let's remove a couple of these. Okay, I got too excited drawing these electrons. Maybe I'll just remove one from here. Okay. 2, 4, 6, 8, 12, 14, 16. Perfect. Okay. So, the take home here is that we have 2 different atoms, but they are sharing some of the electrons. That then makes both of them more stable. Okay. And there are some rules about how to figure out how different atoms will share electrons, or whether they will, because helium here doesn't need to share any electrons to stay stable. But oxygen does. An oxygen atom by itself is not very stable. It needs to share electrons in this way. Okay. So, once again, there's details and things you can learn about that, but I just wanted to give you the overall idea of what a molecule is. Okay. And then we have ions. And I wanted to talk about ionic compounds. So here, I'm going to talk about, and one example would be, I talked about lithium earlier, so let's talk about lithium. Fluoride. Okay, so that means that there's lithium and fluorine. But in this case, it is actually a lithium ion that's positively charged, and a fluoride ion that's negatively charged. And so what this means is that we saw lithium earlier, and it had 3 protons. Okay. But now, one of those electrons around lithium has been removed. So if we just have now two electrons and 3 protons, if we think of one of these negative charges canceling out one positive charge, this other negative charge from the electron canceling out this positive charge, that leaves behind a positive charge. So this is an ion of lithium that's positively charged. Leftover positive charge. has 3 protons in the nucleus, so it's still lithium, but it's positively charged because we removed one of those electrons. Okay, so there's our lithium ion. And yes, lithium ion batteries, this is exactly what's in there. Okay? Alright, and then our fluoride, let's see what's happening there. So oxygen has 8 protons. Fluoride has 9. 9. Okay. So here's our nucleus of fluoride. So here's a little arrow over there. Here's our lithium. Okay. So here's our 9 protons. Okay. So a fluorine atom by itself would have 9. This is just kind of the barrier where the electrons spend their time within this area here. Okay. So we would expect for a neutral fluorine atom that there would be 9 electrons. Okay, so that's true. 3, 4, 5, 6, 7, 8, 9. So I'm just kind of spreading them out equally like this. Okay. So this would be neutral fluorine atom, but fluorine becomes more stable if it has a 10th electron. So it has gained an electron. There's one extra negative charge. So that's why it's fluoride. The name changes a little bit to show that it's negatively charged. It's got one extra electron. Okay. So these are now called ions because they are atoms that are charged. One of them is positively charged, lithium. This other one, fluoride, is negatively charged. These now attract each other in a very special way. Positive and negative are attracting each other, and they form ionic compounds. Another example of an ionic compound is table salt, and that is sodium chloride. It's similar actually to lithium fluoride, except the sodium is +1, just like lithium is +1, and the chloride is -1, just like fluoride is -1. Okay, very similar in that way. So these are all the basic ideas of chemistry, and really what I wanted to get across was this general idea of what an atom is and all the components, and that we can build pretty much everything in the universe that has mass. We can talk about atoms and how they are brought together to create all these different materials and substances that are around us. Alright, well, I hope this was helpful. It's definitely, it was really interesting for me to step back and really think about what are the fundamentals of chemistry. What are those things that are important to know if you just want to have a basic understanding of what is an atom. So I hope this was helpful. If there are any parts of this that I talked about that are unclear, or maybe you want me to expand on in another video, I'm really happy to do that. So just let me know in the comments. I really do appreciate all your comments, by the way. The messages are really great, so thank you for all of that. And have an awesome day.